This is part 4 of section 8.4. We saw earlier that if you just increase the number of times you're compounding in a year, you tend to earn more money. Also, if your interest rate is higher, everything else being equal, you're going to earn more money. What happens a lot of times is we have to choose between two investments with different interest rates that are compounded a different number of times. And it can be difficult to try to figure out which of the two investments is actually best for you. So there is a measurement called the effective annual yield or effective rate. And that is just a computation that says, okay, if we're doing simple interest instead of compounding interest, what interest rate using simple interest will give me the same amount of money in 1 year as this compound interest option, okay? It serves kind of the same purpose as when you're figuring out the unit rate at a grocery store, when you're trying to decide which is the best buy, you want to pay the least amount per ounce of something. Then this is kind of doing the same thing. It's norming our rates so that we can just compare numbers and figure out which is going to be better. The formula for the annual yield, or the effective annual yield or effective rate, is y equal to 1 plus r over n to the nth power minus 1. R, n are the same as they always have been. Y is just the yield. Okay? So let's look at a problem. You deposit $12,000 in an account that pays 6.5% interest compounded quarterly. We want to find the future value after 1 year. And then we're going to use that to figure out the simple interest rate. That's the same. I'm going to do it directly, and then I'm also going to use the formula we have so that you can see that they are the same. Okay? So for the first part here, our principal is $12,000. Our rate is 6.5%. So that's going to be 0.065. Compounded quarterly, so our n is 4. And we're asked to find it after 1 year, so our t value is 1. Okay. So I'm going to find the accumulated value, which is this formula here. A is equal to the principal times 1 plus r over n raised to the nt power. So this is going to be 4 times 1. This shouldn't be too difficult. Adding 1, raise that to the 4th power, and multiply by 12,000. And our accumulated value is $12,799.22. This is regular rounding. That 9 bumps it up to 22. Okay, so this is how much money this particular investment gives me in a year. What I'm asked to do, I'm not going to use this formula just yet. We'll use it in a second so you can see that it's the same. What we're looking for is for the simple interest rate that will give us the same amount of money. Okay, so back to simple interest formula. We want our A value to be this. Okay, so I'm going to do $12,799.22 is equal to the principal. We're still depositing the same amount of money, so 12,000 times 1 plus RT. 1 plus our rate times our time. Our rate is what we're looking for because it's going to be different for simple interest. But the time is still 1 year, so that's technically 1R. I'm going to distribute. okay? Subtract 12,000 from each side, and you get $799.22 is equal to 12,000 R. Divide both sides by 12,000. And let's see what we get. And this is going to give us this is our decimal, this is our percent as a decimal. So this rate is 0.066601, so on. Change this to a percent, which means moving this over here. And we're going to round to the nearest tenth. So this is 6.7%. So the yield on this particular investment is 6.7%. Now let's use the formula and see if we get the same value. Y equals 1 plus our rate, which was 6%, 6.5%, 0.065 over the number of times we were compounding, which is 4, minus 1. Oh, it raised to the nth power, which is 4, and then minus 1. So let's do that. 0.065 divided by 4 plus 1. Now raise that to the 4th power. And then subtract 1. And you see we've got the same ugly decimal we had here, which is still going to give you 6.7% yield.